So my name is Eric. I'm a computer engineer at Nubank. I've been working at Nubank for 2.5 years doing functional programming. I love functional programming, so it's great to actually work with the things that you love. And today I'm going to talk about Stateflow. It's a library for integration testing. And first, to begin with, I'm going to start with I was reading the news early this morning, and it came to some interesting piece of stuff that I want to share. And is this Harvard just discovered that PowerPoint is worse than useless? Unfortunately, I've already done my presentation, so sorry for that. Maybe sometime I'm gonna read this stuff in the slide. That's when I get too nervous and I don't know what to say next. So it's definitely useful for me. I don't know if it's useful for you, but we're gonna do that. Unfortunately, I didn't think of any funny gifts to put in this presentation, so sorry for that. But there will be some live coding. Sorry for that. I'm going to talk about integration testing first, what it is. I'm going to talk about how Clojure applications are typically structured so that we can finally start talking about Stateflow, and then some final considerations at the end. First, integration testing. Oh, this is terrible. Let's see. Okay, we can continue like this. Everything is going to be all right. Integration testing is when you need to test individual software models that they are combined as a group, and is made to evaluate the compliance of a system with specified functional requirements. This definition is stolen from Wikipedia, but it's actually defined by some consortium with a 4-letter acronym that I can't pronounce. This is just for us to be on the same page of what we are talking about. But we want to do that on Clojure applications, so we need to know how we structure those Clojure applications, right? So you typically divide the parts of your running application in components that obey certain protocols. You don't need to do that, but I think that you really should. And then you build production and test mocked version of these component protocols. So that when you are actually testing this stuff, you're testing with the mocked versions of the components, and you can actually have a test version of your system to do the testing with. And the other thing that you need is you need to have a way to start components and their dependencies in order. And the way we do at Nubank is that we use components. It's the short Sierra library, but there are many other components that you see on the next slide. But the important thing is that you need some kind of structure that will represent your running system, and that's important for testing. And that's what we're going to work with. So like I said, there are many component libraries. There's component, there's mount, plumbing, and many others. Stuart Sierra actually has a list for all of them. It doesn't really matter which one you choose, but do choose one because it's important. So once we have this covered, we want to state the problem we want to solve. What we want to do with our system at test time. What do we need to do integration testing? And we we want to do all of these things. You want to be able to poke your system. What I mean by poking, you want to interact with your system, like try this HTTP endpoint and look how your system reacts to it. You want to change your system. You want to update it to, I don't know, some configuration version or some other thing. You want to be able to inspect your system and see what's going on inside it. You want to be able to test properties on it and check if everything is working as you expected it to be. You also want to account for sync behavior, and this is a bit tricky, but sometimes you poke your system and it doesn't immediately react. It takes some time because it's doing something in the background. You want to account for that as well. And finally, we want to be able to reuse and compose your components, your test components, into things that you can use later, not just once and forget, because we don't really like to write a lot of code all the time, the same code. So that's really important. So how we use Stateflow for solving those kind of problems? What it do is that everything you want to do is of a simple form, is the same form. So everything is kind of a function that receives a state. In this case, the state is your system. And it returns a pair of values. The first element of the pair is the return value. And the second element of the pair is the new state. So with this simple definition, we can do everything that we want to do in terms of testing the application. And so on Stateflow, a flow is a combination of things that have this shape and is also of this shape. So what that means is that you may have flows within flows, within flows, within flows indefinitely. But every recursion needs a base case because otherwise you can't do anything. So to build the state flows, you actually need some building blocks, some primitives that we can actually do something with it. So we have kind of just 3 primitives that we can do a lot of stuff. The first of them is gets. And with gets, you pass a function, and it's a thing of the form that it receives a state and returns a pair. The first element of the pair is the application of this function to the state. The second element is the state unmodified. You're going to see later how this works in practice, but first I want to just present this simple pieces. So the other piece is swap. You pass a function to it, and it creates a flow that works like a function that receives the state and returns a pair. But this time, the return value is the old state, and the second pair is the state with this function applied to it. So in this way, you can inspect your system because you can get things from it. You can change and update your system as well. And finally, you have state return. With this, you pass the value, and what it does is just doesn't modify your system, but it returns the value as the first pair of the return values. So with this, what we can do with it, let's go to the repo to find out. Okay. Everybody can see it? Cool. So I'm gonna build a simple flow that will just get the keyword value from my map. So the system that I'm building is just a map with a keyword value and an integer inside it. And I wanna build a flow that will just do one thing, very simple thing. It's gonna get this value out of my system. So once I define it, I can use Stateflow Run to actually run this flow within my system, which is this map with the value 4. And what I would expect from it is that I return the value. So it returns a pair that has as a first element the 4, the value from the map, and the second element is the state unchanging. So this is another example for modifying your system using swap. So it's the same kind of system as a very, very silly one, but it's very useful for this presentation. I just want to increment this value, so I call in update on the value that is inside the map. So what I would expect here is that when running with Stateflow Run, I get a pair. The first element is your old state, a map with value 4, and the new state is a map with value 5. So this way you can change, update, do things within your system. So then comes the flow macro that actually binds and combines the things together. So the flow macro receives a description that is useful for displaying error messages, and you can do then you can pass 0 or more bindings or other flows or more primitives. This is an example from the first flow inc value, but now inside a flow macro. And we expect it to return pretty much the same thing, and it does, but it also returns some description metadata that is used for generating error messages. You don't need to worry about that now, but flow works pretty much the same as the primitives we talked about, but there's this system that stores the descriptions inside the vectors, so you can know at which point where in the flow you are, because you could have flows inside flows like this, and it changes the metadata of your running flow. Now, with flow, you can combine these kinds of things into new things, and that's really where the magic happens. So let's say you want to apply inc value 2 times, so you just write a flow that has inc value and then another inc value, and the result should be that your new system should have the value 6, and that's what happens. You may notice that the first element has a value 5. You may suppose that it should be value 4, that's the initial state, but actually the flow always returns whatever the last statement returns. So it returns value 5 because before incrementing to 6, it was 5. So cool. Other things that we can do with it, we can have bindings inside the flow. What does that mean? It means that if you have our flow that can get the value that they can expect the system, we can sort of bind this value to a symbol and use it inside the flow. So here I'm writing a flow that will return the value doubled. So first I use a binding. This works pretty much like a let binding, but it assumes that the right side element is a flow. In this case, a flow that will just retrieve a value. So I bind this value to this variable, and I can use for other flows downside of the flow to make stuff happen and use this value. So here I'm just returning the value multiplied by 2. So when I run it, what I suppose would happen is that the return value is 8, the 4 doubled, and the system is unmodified because I'm not doing any change to it. So cool, we can do bindings. We can put several flows inside this and do them in sequence. But we also want to do assertions because we want to test some stuff. The way we do with Clojure test, we're using a flow called match. So match is not so special, it's just a flow that will execute a Clojure test assertion. And we can do some interesting flow like this. So in this flow, I'm incrementing the system by 1. Now I'm going to get the value, and when I get this value, I expect is the value incremented by 1. And I want to match that the value is 5. Now I'm saying 4 here because 4 would fail. But I want to check that this is 5. Then I can maybe increment the value again. Now I test the same thing in a different way. Instead of getting the value, I get the whole system. And I check that the system map is a keyword value with the value 6. So if I run this, I expect that the value will be 6, and it is. But what else happens is that some assertions are being made, and nothing happens in the REPL because the test passed. But if we make the test fail, like we expect 5 and we get 4, and we actually run this, hopefully we will get some failure messages, I hope. Let's see. Yeah, you would get something like this. Fail with assertions, you were expected to be 5, but it's actually 4. And another thing about Match is that it uses Matcher Combinators behind it. Matcher Combinators is a library, open source library maintained by Nubank that is very useful for writing assertions. In this case, in this match here, for instance, you get the value 6, but actually, if your system had more stuff inside, the default assertion here is that you match for only what you are interested about. So it doesn't matter if the map has other stuff. you just want to know that the value, that this keyword and this value is inside it, and if you really want to do some equality check, you can do matchers equals, and then you are checking that the map is exactly that and not just other stuff as well. And you can build a lot of other matchers. You can check the library if you like. It's really neat. But anyway, it's run with matcher combinators inside. So you can do bindings. You can do assertions. What about a synchronous test that I talked about? Sometimes you do things in your system. It's rare that this happens, but this sometimes happens. It's very annoying. That something occurs in your system asynchronously, and you need to check, to write a test for it. So in this case, I'm writing an increment, value increment that happens in the future. So we spawn a thread that will sleep for 200 milliseconds, and then it will swap the value of our system. Our system now is made of an atom that has a number inside, instead of just a number. This is more real-life example, because in real life, your systems have atoms inside. You have the same get value, but instead of just applying the keyword value, you also have to deref the atom to get the value. So these are the same versions of the previous flows, but works with atoms. So this is an example that fails. We apply this delayed inc value to increment in the future. We try to get the value immediately. Of course, this is not going to work because you didn't have time to actually increment the value, and you bound this value to the old thing that you had. Then you try to test, and the thing is not 4, it's not 5, it's 4, and you have a problem. So how do we solve this problem within the framework? Is that instead of binding the ref to the symbol value, we can write the match accepts a flow as the left side input. So what I'm saying here is that I'm incrementing this value in the future, and now I'm going to test, and the fetcher, the thing that will fetch my value is inside the test function. And what this is going to do is we'll try to fetch the value, and if it's not 5, it's going to try again and again and again until there is some timeout that you can configure, or it just gives up and say, oh, I tried a bunch of times and nothing happened, so this failed. But if your thing just takes a little while to synchronize, eventually it's going to be 5 as you expected, and the test is going to pass. So this is how we deal with asynchronous tests. And then we can run this flow with async success. It should work. And with async fail, it shouldn't work. I'm not sure why things are not showing the buffer, but I guess live coding never works exactly as we intend to do, but you can trust me. So we have these flows that we can use, we can reuse, because we can accept flows inside the flows, but still we have not defined the test. And how do we define a test using this framework? There's a macro called devflow that it's the equivalent of dev test. So this is would just register a test that will run the flow that you passed. So if I use that flow, pass the name of my flow, I can pass some parameters here. This parameter is my initial state. It's going to be just this map with an atom 4. And here I can pass then one or several flows that we run in sequence. So if I run this, I'm actually registering a test. And as with any Clojure test, we can just run by calling it. And this should do something, but it doesn't. With success, it shouldn't do anything in the repo right now, but with fail, it should print a fail message that is something like what I showed before. Okay, it should print something like this. And notice that in the failure messages you have the path of whatever failed. In this case, the first description of the flow is my async test, is the name of the test. Then we go to this flow called with async. So that's why the descriptions matter. And it also serves as documentation, right? You can, in the description, you can say what you are actually doing. And then this is the description of the match. And you expect it to be 5, but it didn't work out. So the failure messages is somewhat like this. This is generated by matcher combinators. Cool. So that's what I wanted to show in the repo. And I also have some fun facts. So Stateflow is used by 26 services at Nubank as of now, and counting. Apparently some people were crazy enough to actually use it. So cool. And also, if the repository reaches 100 stars, I will make a logo for it. So check that out. You can find the code of this presentation on sample/tutorial in the repo. Also, feel free to ask questions, make suggestions, and propose changes. We are very open to new ideas and to just teach and explain things. So just feel free. So that's what I had to show. Thank you. Any questions?
Hello. Are this library used for unit tests or integration tests?
Integration tests.
But you can use for the flow of states and try to test something in the flow of the streaming of data?
Well, it's mainly used for integration tests. I think maybe it's too much for unit tests. I don't think it really. I mean, you could use for anything that has a flow events around the same state, and you could use for things that are not even testing, if you want. But we build it with the purpose of doing integration tests.
Hello.
Any other question?
Yeah, so one more. I think you mentioned there atoms I'm not familiar with. I believe it's datomic, right? The atom naming that you use there to compare the values. I don't know.
This is a Clojure thing for building mutable state, something that you can change in a safe way,
Okay.
thread safe way.
All right. So my question is more related to the integration test. You mentioned that you can integrate with several services. So do you test today with databases, and what other types of things you integrate today with this integration test?
What we do at Nubank, the integration tests are for a single service, and there are many components to these services. One of them is that maybe the database. We may have also Kafka messages and other things, other components that we glue together inside this system, and we need to test that the whole system works. But it's usually within the same system. We did have a way to do integration, some sort of end-to-end testing using a tool similar with this one, and we could use for this as well, but I guess it's not exactly the tool for it.
Thank you.
So, hi. You talk about asynchronous test, and you said that you can configure the timeout.
Mm-hmm.
And I wanted to know how can you do that?
There are some parameters that you can pass here on the match. I think I don't know exactly the keywords anymore, but it's something like probe timeout, and then you pass the milliseconds and something like number of times you want to try this. So usually it tries every 10 milliseconds for at most 100 times, and we can configure with this. Passing a map here would do that. The keywords are not exactly that because I don't remember, but they are in the code, source code.
Thank you.
So, anything else? Cool, let's have lunch. Thanks.